Welcome to this session on Azure Load Balancer Troubleshooting. If you are managing applications in Azure and facing connectivity issues, you are in the right place. In this session, we'll explore common problems, diagnostic tools, and step-by-step solutions to address issues such as backend unhealthiness, HTTP 502 error codes, and traffic misrouting. Let's begin with a common concern. Why is my load balancer backend unhealthy? This usually relates to health probes. When the probe doesn't receive the expected response from a backend, it stops routing traffic to that instance. This could be due to misconfigured ports, an inactive VM, or traffic being blocked by a firewall or network security group, NSG. We'll examine each of these causes and how to fix them. Typical reasons for an unhealthy backend include incorrect ports or protocols, the service not running or listening, network rules blocking the probe, or a VM being unavailable. Always start by checking the basics using diagnostic commands. For example, use netstat to confirm if your application is listening on the correct port. You can also use curl to verify the response. Ideally, you should receive a 200 OK for your endpoint. These are simple yet powerful tools. Now, let's discuss another issue. What if your frontend IP isn't responding? Start by verifying that the IP is assigned correctly and associated with the appropriate load balancing rules. Even a minor misconfiguration can cause major downtime. Key checks for front-end issues include inspecting the front-end IP configuration, validating load balancing rules, and confirming the health probe settings. Also, review NSG rules and route tables, as they frequently block return traffic without generating obvious alerts. Azure Network Watcher is invaluable in this scenario. Use tools like IP Flow Verify or Connection Troubleshoot to trace traffic paths and identify where blocks occur. Next, let's consider a situation where traffic isn't spreading evenly across backend instances. Start by examining load balancer metrics such as SNAT connections and byte counts. Review backend VM metrics. If one VM is handling most of the load, it's a red flag. Investigate further using NSG flow logs, application logs, and simulated load tests. Also, check for session persistence settings, which can cause clients to consistently connect to a single server, skewing the distribution. Now, what if the load balancer isn't balancing traffic at all? This often points to misconfigured probes or rules. Something as simple as a mismatched port can prevent traffic distribution entirely. For example, if your probe checks port 80 but your application runs on port 8080, the probe fails, the VM is marked unhealthy, and no traffic is routed. Always ensure your probe targets the correct service port to avoid this issue. Intermittent 502 errors are another common frustration. They indicate that the load balancer did not receive a valid response from the backend. This could stem from resource exhaustion, application crashes, or transient network issues. To resolve this, identify the backend that is failing. Check application logs, probe settings, and VM resource metrics. If SSL is involved, review your TLS settings as well. Health probes play a crucial role in all of this. They continuously monitor the state of each backend. TCP probes simply check if the port is open, while HTTP/HTTPS probes expect a 200 OK response. If that response isn't received, the backend is marked unhealthy. With HTTPS probes, there's an added layer of complexity. SSL handshakes must complete successfully. If your application redirects or fails to return a 200 OK response, the probe will fail. Additionally, firewalls or NSGs might silently block the probe traffic. To fix HTTPS probe issues, ensure your backend is listening on port 443, the SSL certificate is valid, and NSG rules allow the probe traffic. Make sure the probe path returns a valid 200 OK response. Avoid 404 or 500 errors. Let's also touch on connection timeouts. Azure Load Balancer terminates idle connections, typically after 4 minutes. This affects long-lived sessions such as SSH or RDP. To address this, configure your application to send keep alive messages or adjust the idle timeout setting in the load balancer. Finally, let's talk about packet drops at the load balancer level. Though rare, they can occur due to SNAT port exhaustion or probe failures. Use diagnostic logs and AZURE Monitor to investigate these cases and understand the traffic behavior. That brings us to the end of this session. Remember, most load balancer issues stem from minor misconfigurations, such as probe settings, NSG rules, or port mismatches. Leveraging AZURE tools like Network Watcher, Diagnostics, and logging can make troubleshooting faster and more accurate. Thank you for watching, and happy troubleshooting.